Welcome to Math with Mrs. Bibb. Today we will be solving quadratics by completing the square and rewriting quadratics in Vertex form. You can see there that the definition for a perfect square trinomial is a trinomial that can be written in the form the quantity ax plus a number squared, and then this can be created by finding a constant that is a perfect square. And let's talk about how you go about doing that. To find your new constant, that's your c, you're going to take your b value and divide it by 2, and then you're going to square that number. So let's look at the first example underneath example 1. To find your new c value, you take your 10, which is your b value, divide it by 2, that gives you 5, and you square that answer, that gives you 25. And I would like to see all this work on your paper, especially with notes, because remember, you write down what I write down. And then for the second part of these instructions, then factor that expression into the square of a binomial. The square, here's the first answer, that's C. The square of a binomial. One wonderful thing about this, even if you don't know how to factor, you can rewrite this into an expression that's a square of a binomial by easily knowing two things. First of all, you'll use your middle variable. That middle variable will go here. So I'll put x here. Secondly, whatever the answer is you get when you divide by 2, that's what goes beside the x. I got a positive 5 when I divided by 2, so that's what goes beside the x. X squared plus 10x plus 25 factors into the quantity x plus 5 squared. Let's go on to the next one. To find your new c, you take your b value of 9 and divide by 2. We don't want decimals, we're going to leave it as an improper fraction. We're going to square that, and we'll get 81 over 4. That is your c value, 81 over 4. And then I'm going to rewrite that as a binomial squared. Remember, you use your middle variable minus x, and then the answer that you got when you divided by 2. That's what we'll put beside of that x. So plus 9 over 2. That is that trinomial factored into the square of a binomial. And then the last one underneath example 1, we're going to find our new c value. Our new c value is b, which is negative 22, divided by 2. That answer is negative 11. And then we're going to square negative 11 and get 121. That is the c value, the constant that will make this expression a perfect square trinomial. And now we're going to factor that expression into a binomial squared. Remember to use your middle variable, which is x, and then one more reminder, the answer that you got when you divided by 2 goes beside of the x. So minus 11. That gives me x squared minus 22x plus 121 factored is the quantity x minus 11 squared. Now we're going to solve by completing the square. This is the second method that I've shown you how to solve a quadratic. Actually the third method, because you can solve by graphing, that's the x-intercepts. You can solve by factoring most of the time, or you can solve by completing the square. And so I added in here, why would you choose to solve by completing the square? You use this method to solve quadratics that cannot be factored. This process creates a perfect square in a trinomial and allows the equation to be solved using the square root property. So your steps are written there. Rewrite the equation with the quadratic and linear term on the right side of the equal sign and the constant term on the left. Make sure a, the coefficient of the quadratic term, is 1. And then step 3 and 4, let me show you, step 3 and 4 up to here, we've just been doing. pretty much, except we didn't add to both sides of the equation. But we have been doing step 3 and step 4 for the most part on those last 3 examples. Excuse me. And after we factor the left side and simplify on the right side, then we will take the square root of both sides, and just like before, don't forget to write plus or minus when you take the square root of both sides. Okay, let's go to example 2. Example 2 has 3 questions. Okay, step 1, rewrite the equation with the quadratic and linear term on the right side of the equal sign and the constant term on the left. So quadratic and linear term, let me, quadratic, linear, constant. Quadratic, I don't have one linear term, I'll have to simplify here, constant. I have nothing here, I'll have to distribute. And then I'll have quadratic, linear, and constant. Okay, let's do what step 1 says to do. It says the quadratic and linear term will be on the left, so I'll keep my x squared plus 2x. On the left side, I'll add 6 to the other side. As I do that, I want to ask you to please leave a space there, and I'll show you why in just a moment. But please, where I have a space, I'll highlight it in green. Where I have a space, we're going to put something in that space on either side. So make sure to leave a space. You don't have to highlight, but if you want to, you're most welcome to highlight there. Okay. Step 2. Make sure A, the coefficient of the quadratic term, is 1. So let's look at my A. Is this A value 1? Yes, it is. So I can carry on to step 3. We're finding our new C. The new C is what's going to go in that green spot. So to find C, you take B and divide it by 2 and square it. So 1 is my new C. And I'm going to add, that's what it says in your steps, divide by 2, square that answer, and add it to both sides of the equation. So I'm going to add 1 to both sides. Okay, that is step 3. Step 4, factor the left side. Just like we were factoring before, it factors into a binomial to the second power. Use your middle variable, and then the answer that you got when you divided by 2 is what goes with what's in the parentheses with the x. So x plus 1, that quantity squared, equals 7. 6 plus 1 is 7. So we factored on the left and we simplified on the right. Now I'm going to take the square root of both sides. The square root of the quantity x plus 1 squared is x plus 1 equals plus or minus the square root of 7. Now I'm going to get my x alone. And I don't see that in the steps, so you might want to make sure to say solve. Solve to get your x alone. So I'm going to subtract 1 from both sides. Do not forget to put that minus 1 in front of the plus or minus. So x will equal negative 1 plus or minus the square root of 7. You may stop there after I show you one more thing. This is 2 answers, negative 1 plus the square root of 7 and negative 1 minus the square root of 7. Those are my 2 solutions. You are welcome to say this is the answer as long as you know that you have 2 answers. You definitely have 2 answers. Negative 1 plus the square root of 7 and negative 1 minus the square root of 7. I want to add that you will leave your answers this way when you have a radical that does not have a perfect square underneath it. And also when you have an I. you can leave your answers like that. If you have a whole number, let me show you where. If this had been a whole number, then I would need two distinct real answers. But we do not have a whole number here, so we will stop there. Okay, let's go to the next one. Step 1 says put the quadratic and linear term on one side. So that's what I'll do. I'm going to subtract 2x. 3x squared plus 6x equals -9. The next thing I'll do is check my a value. Is my a value 1? No, it is not. So I am going to divide everything by 3 to turn that into a 1. So I'll have x squared. Oh, I dropped my x. I found that mistake. Dropped that x. X squared plus 2x, leave a space, equals -3. And remember, in that space, we're going to put our new c value that makes this a constant. So to find that new c value, I take b and divide it by 2. That gives me 1. I square that answer. I get 1. And I add 1 to both sides. The next step says factor on the left, simplify on the right. So step 4 says factor on the left. The left side will always factor into a binomial to the second power. Write down your middle variable. Then write down the answer you got when you divide it by 2. Simplify on the right. -3 plus 1 is -2. Take the square root of both sides. X plus 1 will equal plus or minus the square root of -1 times the square root of 2. I'm going to do two things at one time. I'm going to get my x alone by subtracting 1. Don't forget, your subtract 1 is going to go in front of the plus or minus. And then I'm going to simplify that I. So x is going to equal -1 plus or minus I times the square root of 2. And I am going to say that's my answer because I have a radical. It's not a perfect square, that's 2, and I have an I. So that is my answer. Moving on to the next one, I'm going to distribute first. So I will have 4w squared minus 12w equals 24. And my quadratic and linear term are already on opposite sides like they're supposed to be. Now I'm supposed to check my a value, which a is not 1, so I'm going to divide everything by 4. W squared minus 3w, leave a space, equals 24, and leave a space over there. Now I know I don't have much of a space, but that's okay. So I'm going to put something here and something right beside that 24. Okay, I'm going to find my new c. My new c is b divided by 2, which I don't want a decimal. I'm going to square it. That will give me 9 over 4. I'm going to add 9 over 4 to both sides. Okay, I'm going to factor the left side into w minus 3 over 2 equals 24 would be what over 4? 4 times 4 is 16. 96 over 4 plus 9 over 4. Sorry, so close to the edge. So w minus 3 over 2, that quantity squared, equals 105 over 4. Now I'm going to take the square root of both sides. This is why you don't want a decimal, because you'll not be able to get this exact answer. So I'll have w minus 3 over 2 equals plus or minus the square root of 105 over the square root of 4. So you break up those radicals into 2. And then you'll have, I'm going to add 3 over 2 to both sides and simplify at the same time. So w is going to equal 3 over 2 plus or minus the square root of, let me think about 105 for a second. 105 is 5 times 21. And there's not a perfect square. 21 is 3 times 7, so there's not a perfect square there. So I'm going to have the square root of 105 over 2. You can leave it like this. I'm perfectly fine with that. Or you could see it written as 3 plus or minus the square root of 105 all over 2. Either answer is acceptable. Now we are going to rewrite in vertex form. And we're going to use essentially the same procedure as we did solving by completing the square, except there'll just be a couple little twists to it. So here are our steps. Group the quadratic and linear term together. Keep the constant on the same side of the equal sign since we're not solving. Let's go ahead and do number 1 like that. So I'll have f of x, equals x squared minus 8x, leave a space, plus 19. Okay, so in this space here and this space here, we're going to put something to keep this equation balanced. Okay, make sure a is 1. So my a value is 1, so I'm good there. If it is not, factor it out of the group, so we don't divide by it, we factor it out when we keep it there. Find c for the group terms, add it into the group. Okay, so c is going to be negative 8 divided by 2, b divided by 2, which is negative 4, and square it, which is positive 16. Add c inside the group. So I did that. Now, the next thing it says, multiply c, so multiply your c you've got by the number on the outside if you have one. So 16 times 1, that's positive 16. And I didn't have to do that step, said if you had to do that step. And then step 5 says, perform the operation that will keep the equation balanced. So since I added 16 here, on the same side of the equal sign, I have to subtract 16 here to keep it balanced. So f of x will equal, let's see what it says. I didn't add this, and if you want to add this in here, you can. You're going to factor the trinomial and simplify the constants, because you're going to have 2 there most of the time. So factor that trinomial into a binomial squared. It would be the middle variable minus the answer you got when you divided by 2, and then plus 19 minus 16 is 3. So that is my equation in vertex form. And for me, I really like it in this form because I can see quickly and easily that the vertex of this quadratic is 4, 3. Whereas when I look at this one, I cannot tell that quickly that the vertex is 4, 3, but I can tell the vertex is 4, 3 from here. So I really like rewriting in vertex form because it just makes some things easier. Okay, let's do the next one, g of x. I'm going to group the quadratic and the linear term together. And then I'm going to leave a space and put plus 90. Okay. And And don't forget that we are going to put something here and here. I'm going to find my new c. c is b divided by 2, which is 10, and you square it. That's 100, and that's what I add inside of the parentheses. Then those steps say to multiply c with the number you factored out, which we didn't factor anything out. So we technically have plus 100. And how do I balance out on the same side, adding 100? Well, you subtract 100 here. 100 minus 100 is 0. Okay, and then my last step, factor that trinomial into a binomial squared. So g of x will equal a binomial squared, middle variable, and plus 10, positive 10. Then 90 minus 100 is negative 10. So that would be my vertex form. The next example, I am going to group my quadratic and linear term together. Leave a little space, minus 4, and don't forget in this space, oops, I think I was erasing. In this space, we're going to add a number and then subtract a number most of the time out there. Okay, so let's find c. c is b divided by 2 squared, so 9 over 4. Add 9 over 4. And then remember, you multiply your c with the number on the outside if you have one. So 9/4 times 1 is plus 9/4. And then to balance out adding 9/4, I subtract 9/4. So I will have h of x equals the quantity x minus 3 over 2 squared. And then I have negative 4 minus 9/4. So negative 16 over 4 minus 9 over 4. So I'll finish it down here. h of x equals the quantity x minus 3/2 squared minus 25 over 4. That is the third one of example 3 written in vertex form. Last example, example 4, I have 2 problems to do here. It says rewrite each function in vertex form, then name the vertex, axis of symmetry, and determine if it has a maximum or a minimum value. And I want to point out right away that we can tell right now if this has a maximum or a minimum value. This parabola points up, this parabola points down. This points up because A is positive, this points down because A is negative. So right now I know this one has a minimum because it points up, and I know this one has a maximum because it points down. And I'll write that in just a minute, but I know that before even beginning, that minimum value, maximum value. But let's go ahead and put it in vertex form. Okay, so I'm going to group the quadratic and linear term together. I notice right away that I have an A value there. So I'm going to divide by 4. It said on the previous slide, it said to place that factor, we're factoring it out, place that 4 on the outside and then divide both of those by 4. So x squared minus x. Leave my space, minus 5. So I'll do that one over there. Okay. I'm going to find my new c value. C is b divided by 2 and square it. So that would be positive 1/4 plus 1/4. Now I'm going to multiply 4 times 1/4. I'm going to write that out. I'm going to multiply 4 times 1/4. And that is 4 over 4, which is 1. So I have added 1 here. I've added 1. To balance that out, I am going to subtract 1. So now you can see I added 1 and subtracted 1. And I'm going to simplify now. F of x will equal 4 times the quantity x minus 1/2 squared, and then negative 5 minus 1 is negative 6. Oh, I don't know why I put that there. Now, my vertex. My vertex is HK. H is 1/2, because it should be minus. 1/2, negative 6. That's my vertex. 1/2, negative 6. And my axis of symmetry is x equals 1/2. And then this one has a minimum value because A is positive, it'll point up, and that minimum value is the y-coordinate of the vertex, negative 6. Minimum because it points up. And A is positive. Okay, the other one, I'm going to group the quadratic and the linear term together. I'm going to divide by negative 10. I'm factoring that out. So negative 10 will go here. X squared minus 1/2 x will go here. I'm going to find my new C value. So C is going to be negative 1/2. I don't want to write it that way. What's the same thing as dividing by 2? Multiplying by 1/2. Negative 1/2 times 1/2, which will be negative 1/4. Then square that. That's positive 1/16. So we're adding 1/16 inside. Oops, wrong. See, I've got ahead of myself. Adding 1/16 just inside the parentheses. Now, I'm going to multiply negative 10 times 1/16, which is negative 10/16, which is, they're both divisible by 2, negative 5/8. So technically, I have subtracted 5/8. So to keep this balance, I will add 5/8. So g of x is going to equal negative 10 times the quantity x minus 1/4 squared. And then I'm going to do minus, it's got to be 8 here, 24/8 plus 5/8. So g of x is going to equal negative 10 times the quantity x minus 1/4 squared, and that would be minus 19/8. And then my vertex would be positive 1/4, negative 19/8. My axis of symmetry is x equals positive 1/4, and it has a maximum value because A is negative, it's pointing down. So it has a maximum, and that maximum value is negative 19/8. And that is this set of notes. I hope you have a wonderful day.